Continuing with our playlist, we are going to now solve the section D, Python data structures. We are going to use a Jupyter Notebook for writing the code. So let's shift to Jupyter Notebook. Here we have the first question where we need to compute the mean of a list that is given as a equals to 2, 4, 6, 8, so on. What we need to do is we are going to import numpy as np, and we created this array, and simply we are going to use the mean function of the np module to calculate the mean value of this um, array, right? Next, we need to convert this list into a numpy array, which is extremely easy. All we need to do is to just use the np.array function. This kind of acts like a constructor and makes a new object. Then we need to create a data frame for from dictionary A that is mapped to 1 and 2, a list of 1 and 2, and B that is mapped to 3 and 4. So we simply import pandas, and we use the data frame function to create this data frame. So it's quite simple. We just call pd.dataframe, and inside of that we simply replicate the same structure as given in this question. Now, the fourth question says replace all the missing values in a data frame df with column mean. So, in order to do this, this is kind of like an imputation operation. We simply call the fill na function, and in that we need to pass the parameter that should be used for calculating the for that is basically used for the filling of the missing values for the imputation. So this is the df dot mean, and this will basically impute all the values with the mean values inside the data frame. Now we need to display 5 rows of data frame df. So by default, df dot head function will show us the 5 rows of the entry. Next, we need to plot a histogram of column height using matplotlib. So to do that, we basically add a histogram of data frame for the height column, and then we are assuming that there is a distribution of height with the frequencies. So we just add in the two labels and just call the show function to actually uh, open the new window and actually see the results, right? The seventh question is hot encode categorical column color. So again, this can be done via the pandas module. The get dummies function will basically use this the column provided in a list format to generate the one hot encoding columns separately. This is basically a data representation technique. This allows us to also do some feature scaling. Next is compute correlation between columns x and y. So to do this, we just need to select the x column, and dot corr will basically basically a function call that will accept another column to find out the correlation. This data structure then can be printed to access the values. Next, we need to find unique elements in a list using Python set. This is extremely easy. The set function will create a set that only contains the unique values of a list. Next, we need to add a key value pi as that will be mapped to 3.14 in a dictionary D. So this uses the this is specific notation of a square bracket. So inside this we have this pi that is linked with 3.14. Then we need to create a deck and append elements to it. Again, we need to import the deck from the collections module, and then we append the values into it using the append function. Pop smallest element from a heap. So this should be min heap. So for popping an element from a heap, we first need to actually have the heap. So we will import that heap, and we will heapify the values that are given inside the function constructor. And to find the smallest element, we need to use the head pop heap for pop function to get out the values. Next, create a numpy array of zeros with shape 3 comma 3, that is a 3 by 3 shape. So numpy has a function of dot zeros that can actually have a tuple that contains the dimensions required, and thus we can obtain this zero arrays vector. Next, we need to convert the column date to date time in pandas. So again, this is a simple conversion. We just need to select the column that is required and perform the operation using the to date time function. Next is filtered data frame, where scores are greater than 50. So to filter the data frame, we will just select that column and apply this condition inside the data frame square bracket notation. And thus the filtered data frame will have the score that will have the entries that have the column of score greater than 50. Thank you for watching this video.